Guten Tag, everyone. In this video, we're going to be discussing symbolic notation and truth tables. Our whole goal here is to use this symbolic notation to represent logical statements. So for those of you that haven't really figured this out throughout your entire education and having math every year, math is a language. It is a language of logic. It is a discipline, and it discusses, organized ways of thinking. There is a right answer, and there are rules that must be followed. So we're going to be looking at these conditional statements, and we're going to be using symbols to represent these statements, and we're also going to, use a truth table in order to really organize our thinking here. So there's a couple of symbols that we have, and one of which is an arrow. So an arrow, what that means is implies. Alright, and it connects the hypotenuse not the hypotenuse, the hypothesis and the conclusion. And then if we were to talk about negation, that means when we include the word not, so it is raining is a positive statement, it is not raining is the negation of that statement. So that symbol right here is that kind of little squiggly line there, alright? So that would read as not P if I were to write it like the little squiggle symbol and then the P. Alright, so symbolic notation, we have these if-then statements, and you can kind of see the original conditional statement and then the converse, inverse, contrapositive, and then when that is created into a biconditional statement. So I'm going to go line by line here. So let P be the angle is a right angle, and Q be the measure of the angle is 90 degrees. So P and Q both represent particular statements here. So if P then Q, it's going to be written like this. So if an angle is a right angle, then its measure is 90 degrees. Alright, and the converse of that, we swap our hypothesis and conclusion. If the measure of an angle is 90 degrees, then the angle is a right angle. So that is going to be written as Q implies P. In the inverse of our original statement, we simply negate both the the hypothesis and the conclusion. So if not P, then not Q. So that is not P implies not Q. If an angle is not a right angle, then its measure is not 90 degrees. Alright, and a contrapositive, you swap the hypothesis and conclusion and negate them as well. So it's a contrapositive is a combination of the converse and inverse. You can take the inverse and then the converse, or you can take the converse and then the inverse. Alright, and that statement would be not Q implies not P. If the measure of the angle is not 90 degrees, then the angle is not a right angle. And then biconditional, what biconditional has here is this if and only if. So it works both ways, and it means that it can only work if it does work both ways. So an angle is a right angle if and only if its measure is 90 degrees. And the way that they write if and only if is that arrow. Alright, the double-sided arrow that goes both ways. So in order for this to be true, it has to be true forwards and backwards as well. Alright, so let's look at example 1. Let P be the car is running, and Q be the key is in the ignition. So write the conditional statement, P implies Q in words. So you are going to include an if and a then in there. Alright, so that first conditional statement is if the car is running, then the key is in the ignition. And then in order to write the converse, we swap the hypothesis and the conclusion. Alright, so that would be Q implies P. If the key is in the ignition, then the car is running. And then C, the inverse, is not P, implies not Q. And that in words is if the car is not running, then the key is not in the ignition. And then finally the contrapositive here, not Q implies not P in words. It would be if the key is not in the ignition, then the car is not running. Now you can read through these one by one and figure out if they could actually be true or not. So we're going to use truth tables to actually, figure out this whole mess. When are these statements going to be true or not? Alright, so truth tables. The truth value of a statement is either true or false. Alright, so it's got to be one or the other. There's no in between. You can determine the conditions under which a conditional statement is true by using this truth table. The truth table at the right shows the truth values for the hypothesis P and the conclusion Q. The conditional P implies Q is only false when a true hypothesis produces a false conclusion. Alright, so it is only false overall. The entire statement there is only false when the true conditional statement, so when the hypothesis is true, but then the conclusion is false. If you're a fan of the Pirates of the Caribbean, there's a scene where Captain Jack Sparrow is, talking about, being a liar and being trustworthy, and whether he's telling the truth. It's at the very, very end of the first movie, I think, and it's definitely one of the better depictions of how I kind of visualize this table with all the knots and the what's true and what's not. So, without further ado,
I'm dishonest. And a dishonest man you can always trust to be dishonest. Honestly. It's the honest ones you want to watch out for. Because you can never predict they're going to do something incredibly stupid.
So if you listen to what Captain Jack Sparrow is saying is, you've got to watch out for, dishonesty here. So we got to watch out for when things are true and false. So if our original statement, our hypothesis is true, we've got two options. We've got true and false. So if the conclusion is true, then the entire if-then statement, P implies Q, is going to be true as well. Now, if the output, or the conclusion here, is false for a true hypothesis, then the entire if-then statement, the entire conditional statement, is going to be false. Now, if I start out with kind of something that's false, a dishonest man, you can't really trust them either way. We don't really know what's going on, so we're going to say that those entire conditional statements are true as well. So, let's look at an example and try to depict this mess. So use the truth table above to make truth tables for the converse, inverse, and contrapositive of a conditional statement. P implies Q. Alright, so we're going to be using this table above and adding in some additional, columns here for what happens when we take the converse, inverse, and contrapositive. So here, for the converse, this is the easiest one to start out with. We swap from P implies Q to Q implies P. So we're going to be going true, true. That produces a true statement. Now that this hypothesis is false, it's going to produce a true statement no matter what. And whenever the hypothesis is false, it's going to produce a true statement. So here, the hypothesis is true, and the conclusion is false. So this is my only option that's going to come out false. And for the inverse, I need to first find whatever not P and not Q are. So I'm just switching out those values. So what's not true? That would be false. So as you can see, all of those values are going to be flip-flopping exactly what they are. Alright, so true becomes false and false becomes true. So first I have to set up those two columns. And then for the inverse, I use those values, and if my hypothesis is false, so that are these two rows, alright, the entire conditional statement is always going to be true. The only one I have to watch out for is if the hypothesis is true and the conclusion is false. That is my one false row here. Alright, and it's going to go in a very similar fashion for the contrapositive. The only thing that's different here is we are going the other way. So false implies anything, false implies anything, except that I read those backwards. They actually switched my Q and P here. Alright, false implies anything. So these two rows should definitely be coming out true. And true, true, that produces a true conditional statement. My one problem child here is this row. Alright, so here are your practice problems for today. If you guys have any questions, please feel free to email me. I look forward to hearing from you guys. Good luck.